Hello, and thank you very much for following us. In this video, I'm going to show you how to generate this wind. This is the Onera M6 wind. This is a classic for CFD simulation, but we're going to start from the beginning, generating the geometry. You see here that I already have the geometry, but I'm going to show you a few tricks and a few techniques how to do this. And then we're going to do it step by step. We're going to generate mesh and everything. But today we're going just to focus in one part of the wind, generating part of the wind. So as you look for this in the internet, you will find a lot of information. Probably here you have the Onera site. And here you have that, you will see that you have plenty of information. And here you have everything you need to generate this wind. It's relatively easy, but there are a few things that can make things a little bit complicated. Further, also you have this website, and if you don't find there is an article or publication where they give you all the coordinate of the cross section there. If you don't want to go to that one, just come here to this website, and then here you will find some files now with the coordinate for this airfoil. So you will have this one that will correspond to the open section, the trailing edge. It is open, and then you have the other one that corresponds to the closed airfoil section. So it is a symmetric airfoil, so we have only half the coordinate, so we need to duplicate the symmetry mirror, but we're going to do everything in onshape. So just get geometry, get coordinates, everything. Just look at your reference systems, how the drawings, how we're going to do everything. So we move to onshape. So here in onshape, we already have this document. I already have this public document. So if you want, just look for openfoam Onera M6, and you will find everything, how I did it. So just feel free to find this document. So what we're going to do in this case, so look at that, we have here everything, even we have here the tip, we round it here. So this is the most difficult part, how to do this. When a lot of people get in trouble how to cross it there. So there are some specific technique, lofting, how to do it. So basically today we're going to stop here. Okay, we get the coordinates, everything, okay, the cross section, and we have our wind there, as you see. So then, if you want, you just can do the mirror to have the whole mirror, and then the whole wind. And then in the next video, we're going to do the tip to show you. I'm going to show you there how to do, because there are a few picks and clicks that you need to create new planes, projections, but it's relatively easy. So to do this, let's go and let's create a new document. So I'm going to do it kind of from scratch. So I create a new Part Studio. So probably the most difficult part here is how do I import the geometry. So I already have a feature script that I use to import airfoil geometry. So as you see here, you will have this tab here, and basically this is the script, okay? You don't need to modify it, you don't need to do anything. The only thing is that you need to import your geometry, your coordinates. So see here that I'm importing the coordinates in CSV format. So this is something very important. So here you see that I have a subfolder airfoil coordinates, and I already here I uploaded this file. So if I download this file, I will show you what do I have in this file. Okay. So this is a normal file, CSV format. See that I just added the comma. So then you load this file. To load the file, remember you go here, insert new element, import, and then you can import your element. So here you can import CSV files, but also STL files or other CAD geometry. So find the geometry, or load the geometry, then you will have all those files available for your current project, okay? So this is what we do here. So see that we're importing. First we load that information, and then you import that one. So if you have a different airfoil, what you need to do is just see here that you have this icon here, import. Just put import files that you have in your project, and just choose the one you want to import. So if you have those files in other documents, you can find it in another document. So see, for instance, you come here, click. Okay, I did it twice. see that I'm importing the file. So you have it here, and then I give it a name. So this is a little bit, you can read the documentation, how does it work. So basically, I'm giving a name. So here I will call it Onera V3, I already have it here. So this is the name for this imported file. So then this is, this is when I create the airfoil when I import it, so I'm giving default measurement. So here you need to do anything. Here you will see this in effect when we go into our part studio and when we design the part. So here I am creating an enumeration. So we are going to have the suction available in our workspace. So here I'm creating kind of the menu. So I give it this name, and here also what do I want to do with this data. So we're importing the data in CSV format, so I can read this data and convert it to a spline, or I can read that data and use a polyline. In this case, we're going to use a spline. Okay, so this is the name that we're going to do. We're going to have in our feature list, and here is what we're going to do. So see that the airfoil on a V1, just do this one depending on your selection, okay? So for instance, let's say that my selection is Onera V3, which is the same as V2, but just to show you how to modify. So if I choose the Onera close action, I would read this data Onera V3, and then you will do the operation, whatever you select. So it can be polylines or points. So basically, in general, dependent, remember, you need to import your data, give it a name, and then just be careful here as well. You need to give it a name, what you want to do according to your selection. So for instance, the Onera close here. So these are the options that I have. So in my menu, when I have this option, I will read the data V3. I'm going to show you that right now, how does it work. So we have our data, we have our documents. So what the first thing is that I want to import those coordinates. So go here, custom features in this workspace, and here we already have this feature script that we created. Click here and see here that exactly what you saw in the feature script in the source code, you have the options available here. So I want to use the closed action. You have the choice between a polyline or a spline, so let's use the spline. And this is very powerful. This is what I really love here, that we can choose the plane where I want to project that one. So I want to project it in the front plane, or you can create your own plane. So project it there, and then you give it dimension. So here I'm getting an error. I guess it is in my feature script. I guess, let me, probably it's the naming convention. So let me put here, no, V2. Okay. So as you see, also you can do all these modifications real time. There's no problem. Okay. So we have the imported geometry here, and see that also I can give you the default length. So in this case, if I go back here, you see that the length of that airfoil and that the root is 805. So you go here, 805.9, and this will be my profile. Okay, this is what I just imported. Okay. So for instance, I can change the name for the new ones. You have a new one. You click here, commit, just to update it. Everything is done real time. And then your document is also updated real time, as you see here. Okay, so now that we have our airfoil, we did it in a spline, but if you want to do a polyline, it's just pretty much you connect it point by point, but it's better to use a spline here. So now we need to create the cross sections and then do a few operations. So basically what we're going to do is create these lines here to have the platforms the wing, then project this airfoil here, and then we go and do a loft, and we have our wing ready. So the first thing is that we need to have here a closed airfoil. As you see here, we only have here, that spline, we need to have a closed section to do all the operations to convert it in 3D. So I choose sketch. I will sketch here in the front plane, the one where I imported my airfoil coordinates. And then I will choose this option. So I will project this spline into my current plane. So see that we have it there. I can hide the imported airfoil. You see that we have our spline there. But it's still, this is an open line, an open body. So we need to close. So I will click line here. So now as you see here, it is shaded. This means that this is a face that I can use to construct 3D objects. And if you want to put some dimensions, so you just put it here. This is the one we gave it when we imported. So we close that one. And at this point is I want to create, for instance, a 3D body. I can go here, select, and then just do an extrusion, and you have your 3D body. Or also you can do revolve. For instance, this one, select this face, and I want to revolve around this axis, and then you have your body revolution there. But that is not what we want to do. So what we want to do is that we already have here, remember the airfoil is symmetric, so that's why we have only half the airfoil. So you can also put the complete airfoil, it doesn't matter. So we have half the airfoil, we have it here, we need to create it here, but first we need to create these construction lines, construction geometries, okay? So we know here that in the leading edge, we have this angle 30, and we have this distance where these lines intersect. So let's construct these support geometries. So I will do those sketch here in the top plane. So I select here, top plane, and I'm ready to sketch there. So this white dot is my 0, 0, 0, the universal starting point. So that one is available in every plane. And then let me just draw some lines. Okay, it doesn't matter. Here I'm not giving dimension, just drawing some lines. So see that I want to start from this point, but this point is not available in my current sketch. So remember, you need to project it, click here, now it's available, click here, and let me create just a few lines. Okay, so we have this, and I need to give here an angle of 30 degrees. So how I will do, so I will go here and see those that line. That means that I wake up that point. That is, when I click here, my point will be perfectly horizontal with that one. So this is really powerful, okay? So you want to wake up points, just hover close to, and then you see that those points are becoming awake. So in this case, let me awake this one. So here, and this line is vertical. You see that vertical line there, that means that it's a vertical line. It's okay, so let me create this line here. And I want this line to be a construction line. Okay, so you have this option here, and I will convert it to a construction line. Okay, and I want to use it as a reference to give the angle. So click here, then put your angle here, 30. Okay, so we have our angle there, 30. Let's take a look at the geometry. Okay, so I have this distance here as well, so I can create that distance. So I can go here, from here to here, and the distance was 1196, 1196.5, I think. Okay, let me check, 11.3. So I have the distance here, okay, I have my angle, okay, and now I can make this one, remember this point is aligned with this one, so I can create a coincidence, so probably I can say that this is a horizontal, want this one to be coincident with this one, and see that now they are aligning. But at this point, okay, we need to create a little bit, just a few more sketches. So I want to create this reference distance. So which will be this line. So I will go from here to here, to 7, I think, to 7, to 4, to to 7, 3, 4, 5. Okay, so we have our reference geometry. Okay, and now let me do an extension. Okay, from here, let me wake up this point here. Okay, see, I have that line. I want this new line to be parallel with this one, and I want this one to be a construction line. Okay, so this is a construction line, and now this that I have here, this is also a reference line, so I can erase this one. Let me erase it. I don't need it. So look at that. From here to here, I want you to be a construction line. Okay, so we're done there. So look at that. What we have done is this. So this line here intersect here. We have this angle here, and I know this distance, and now I will project my airfoil in a construction plane here. So let me add a final line. So I want it to be vertical coincident this one. So basically, this is what I have. Okay, so here is where I will project my new airfoil, and I can use these continuous lines as support line to do my lofting, as we're going to see later. Okay, so our next step, that now I have the point here where I know I can create my construction plane to project that airfoil. So there are many ways to do that one. I will show you, for instance, we know that distance, so probably you can do an offset of this plane a distance to this one. But I will choose to do plane and point. So I want to use this plane and I want to put it here. So automatically we'll put it there. And now here in this plane, I will do the projection of this airfoil and some scaling, but because you see that it's smaller. So let's do how to do this one. So now let me sketch here. I will click here. Remember that this one is the tool you use for the projection, and see that it is projected here. So I also want to see constraint because I want to raise a few constraints. You have these constraints here, means that you are forcing this line always to be the same as this one. So you are not able to translate this one. You see that one because all lines are black. When they are black means that it's fully constrained. You cannot modify anything. So let's erase this constraint. You click there, click there, click there. Okay. And now let's add some other constraints. So this is a coincidence. So I want this point to be coincident with this one. And now I want this point to be coincident with this one. And as you see, the airfoil is automatically scaled. And it's shaded, so it's a closed surface. So this black line here means that it is fully constrained. This one, blue, means that there is a degree of freedom, so you can modify it, but in our case, it's okay. Now what we need to do is just do the lofting. So we know that we have seen extrude, but extrude, we cannot use it here because extrude is just linear extrusions. Revolve, it is answered about revolve. Sweat basically will take this face and you will choose a sweat path. So you choose this one, we'll do that right this one. But what we want to do is from this face to this face. And the tool to do that one, it is this one, the loft. This is the most powerful tool, would let you create basically any kind of geometries. So we choose airfoils, the sections. So we have two sections. You can have many sections, okay? So it's up to you. What is very important, you need to select that then in order. So if you have a start section here, it needs to go 1, 2, 3. You cannot go from 1, 2 to 3. So select these sections in order. And you see here that we already have our wing there. So the next step will be, I don't need it, but I will show you. For instance, I can add guidelines, and click here. So this loft from this face to this face will follow this path. Okay, So in this case, we get the exactly the same behavior. So for instance, so if I go back here, I will show you, I will generate a new shape here. So I'll go here. This is spline. Okay, so I will go something like that. Okay, there is. Okay, go loft, and my guideline I want to be this one. So see that now it's following that guidelines. Very important about those guidelines, they need to intersect your faces, your profile. So it's this point here where it starts doesn't intersect this one, you would get an error. So in our case, we would like to keep this one. And this is our NACA win. So just to finish for this tutorial, I want to add here at the rounded sections. You see here in the cases, the experiment, there is unrounded. So about that one, there is not much information written. You only have the cross-section dimensions of the win. So there you need to play a little bit with imagination, creativity. So I will show you how to do it in a few methods. Okay, so the first and the simplest method, probably you already imagine that one, you can use a revolve, we already did it. So we create this face, we revolve this face around this axis. So for instance, can go here, revolve, select this face, revolve axis, this one, and I want to create a new part. Okay, see here that you have the option to add. So you are adding this one to the previous geometry. I want to have different parts, and I will show you later why I'm doing this. And I don't want a full revolve, I just want a one directions, and this is 90 degrees. Okay, click here and see that you have the tip there rounded, nice, but see that this one probably is not decidable. So what we're going to do in another video is just to create a guideline as we did with the loft. Okay, so we're going to create a center profile, then we're going to loft it until this point, and then we're going to add two guidelines, one here and the other one here. So probably this guideline here is okay, there's no problem there. We have problem here, so we can add a guideline here just to smooth this transition there. Okay, so our final step, it is just create the symmetry. Remember, this is a symmetric win. So here you have the mirror action. Click here. I want to create a new one. Okay, first let me create a boolean. So I have those two parts. So let me unite this one with this one. Okay, so now we have a single part. And from this one I can create a mirror. Remember, there are many ways to do things, so probably for you it will be better to do the mirror. It's up to you, okay? At the end, we need to get the single geometry. And the mirror plane, it is this one here. And voila. So this is our Onera win, ready to go, ready to use, using these geometries, these dimensions, okay? So perfect win here. The only detail will be here to modify a little bit. We need to modify the win a little bit there. But we're okay. Something else interesting that in the experiments, the win was divided in two parts. Okay, so you have the upper and lower surface. So maybe for us, it will be also a good idea to split the win into parts. Okay, lower and upper surface. So basically what we can do is split this geometry. We know that here, when we mirror, I can say that I want to create a new part, okay? So see that you have two different parts, okay? But for instance, if you add everything and you have a single part, we can split this part also. So see here that you have the tool split. So I want to split this body using what? This plane. I know that this plane, the top plane, is the one that will split everything in the middle. And see that you have your two parts that you can export and do the geometry. So the last part is just go here, right click, export, and you can export your geometry. Okay. So as we're going to work with openfoam, just put it in STL, but you see that you have all the most common CAD formats. You have SolidWorks, that's probably the most universal one, and then many actions. So export in meters, so we work in millimeters, but then we're going to export in meters. As openfoam works in meters. You hit OK, you press OK, and you will download that file. You see, you download everything. And just to show you here, I already have the wing here. In this case, I have a one section, so this is our STL that we can use in openfoam. It's no problem. Okay. So just keep this geometry there, because the next video we're going to work here and the extreme in the tip to round it. So what I want to show you, that there are many ways to do that part. So for instance, I will show you what I did here in this case. Basically, I think I used 3 different methods. So as you get this video, you will get, you can reproduce everything. So the first thing is that I created this sketch, okay? And this sketch is, if I will recall, it is a projection of this revolve. So I did the revolve, I create a plane, I think I put it at about 20% of the aerodynamic out of the core here in the extremes. I don't, we are going to see that later. So you create this section there, and then what you do is just a loft from here to a point here, following to guidelines. So we go here. Okay, let me close the sketch. So we go to the loft, and we get this. Okay, so basically we get the same result of the revolve. I know here I have a different loft line. So if I click here, see that I have this edge and a second edge. Okay, so see that I'm following exactly this edge, which is perfect for me. But then to avoid the problem as we have in the revolve, I created a second edge, which doesn't have that tangency here. You see that goes normal to this face. In this case, I created a spline and I try to make it here continuous, okay, following the tangency. So that one, I think that sketch should be. Okay, it's this sketch. So I see that I created my spline there. And the beauty about working when you work with parametric tools is that you modify this, automatically your CAD will be modified, your final result. So here, given an error, probably it is a self-intersecting. So let me put it here. So automatically everything is updated. So let me do a few undos there. So okay, my original geometry. So see that I use the revolve to create this section, and then I also did another one, which was I think it's this one. Okay, so I have a second sketch that also I created using a spline. So this is different to the one a little bit bigger, so it's up to you how you want to do. So in this case, probably would be a good idea not to use the revolve as it will be tangent to this one. And also, if you want, you can add more sections here to have a smoother transition. So you see our final result. This one, it's not very smooth here. You see, so probably adding another section here to improve that one, but. So you take a look at all the results and the actual geometry. Maybe something similar like this won't change much your final result. I hope here in the tip. So that was the first part of the tutorial. Thank you very much for following us, and well, see you in the next part where we're going to work in the tip of this one. Bye.